So in this video, we are looking at the area of a triangle formula in non-right angle trigonometry. I've actually done a video on this previously where I went through slowly the derivation of the formula, discussing basically why this formula looks the way it does here or here or here. So if you're curious as to how we get this formula, please look at that one. But in the Year 12 Standard 2 course, we're not expected to derive anything. We're just basically applying the formula, applying the rule, okay? So we'll go through it quickly, then just try a couple of practice questions. Now, for this one, typically when we've been given a triangle with a side, and what we call an included angle. Now, the included angle means the angle in between the two sides. Then we can use either one of these formulas, but typically what you see on at least the HSC reference sheet is this one. So if we take this side to be A, this side to be B, and this angle to be capital C, so that's angle C, the angle opposite the side C, we can apply it straight into this formula to find the area of the triangle. Now, all of these sides, for example, side A corresponds to, it's the side opposite angle A. Side C is opposite angle C. And we're going to look at how this will basically look. So this is how I'll do it basically, just applying this formula that I've highlighted in green. Don't let it confuse you too much. You can see with some of these examples, they've given you A, B, and C. I will just do it using this formula. As long as we remember we have the two sides and the included angle, that's all we need. Now, in example 1, we want to find the area of the triangle. The two sides that we've been given, we're going to label these A and B. And this angle is going to be angle C. Just using this rule. You can call this, if you want to keep it consistent with these letters, you can call this B and then this one C and that angle A and use one of the other formulas. But this is essentially how I'm going to do it because this is the one formula that you're given in your HSC formula sheet. So we're going to write it in our formula. So our area equals half times A times B times sine C. And we are just going to substitute these in. So we have half multiplied by 20, multiplied by 32, multiplied by sine of 36. So once we do this, we just write this into our calculator and it's saying to the nearest square centimeter. So we're going to write all this in our calculator and we get 188.09 ... which equals approximately 188 centimeters squared to the nearest square centimeter. Example 2, we're going to do a similar thing. Now, what you may be noticing here, what makes this question harder, is that we're given this side, but we're not given the included angle. Our our area of a triangle formula only works if we have two sides and the included angle to substitute into our equation. So we need to find this guy in here. Okay, now we know that all triangles add up to 180 degrees. We can say that angle DFE equals to 180 minus 64 minus 43. So we want to find the angle size first because in order for our formula to work, we need the included angle. So this gives us 73 degrees, and this is now what we are using in our formula. Now we have our included angle. So once again, we're going to write the area equals to half. Let's label these actually, A, B, sine, and that'll be sine of that angle C. So we have half A, B, sine C, which equals to half times 21 times 28 times sine of 73. Once we have that, we put it into our calculator and we will get, now this is saying to the nearest square centimeter again, so we'll go 281.15, which is going to equal to approximately 281. And this is in centimeters. squared again. Don't forget your units, and remember, we are looking for an area, so it has to be centimeters squared. Now, the last example is actually a past HSE question. So it's a slightly trickier question, a multiple choice from an earlier HSE. We are going to work through this question, but we need to work backwards because they've already told us the area of the triangle, and we're trying to find this side x to the nearest whole number. Now, we have the two sides, 30 and x, and we have the included angle 44 degrees. So I'm going to call 30A, I'm going to call XB, and I'm going to call 44 degrees my angle C. So before we do anything, I'm going to I'm going to write out my formula. Now, I'm going to substitute in all of the relevant information. So my area is 250. I have half times 30 times x times sine 44. Okay, so just to clean this up a little bit, half times 30 just gives us 15. So it's basically 15 multiplied by sine 44 multiplied by x. Remember, we're multiplying, so I can move the order around here as we need. Now, I've done it in this way just so we can see that if I want to isolate x, I want to divide both sides by 15 sine 44 in order to get x on its own. So I'm going to divide by 15 sine 44, divide this by 15 sine 44. Then I get 250 over 15 sine 44 equals to x. And once I put that in my calculator, I will have to just round this to the nearest whole number. But I notice that I get x equals 23.99 ... And I can see that if I round that to the nearest whole number, that will give me 24. But that brings us to the end of this video. This is how we can apply our area of a triangle formula and use it in some harder questions like this one to work backwards with an equation to find an unknown side. Thank you so much for joining me, and I'll see you next time.